All right, hi guys, it's Miss Gallant again. So here we are. We're on. Let me refocus this. We are on Activity 2 of our Unit 1 review. We're going to go through the guided practice, and that's where we're at. Okay. And if you notice, each page has a different symbol on it. So Activity 1 was the Aquaman symbol. Activity 2 is the Batman symbol. I know that's kind of super dorky, but I just want to make sure like you can easily get to stuff. So we are on Activity 2. It's the Batman page. And let's go ahead and jump right in. So Activity 2 was all about solving equations. Solving linear equations. Let me throw that out there because once we got to like Unit 5, we were starting to solve quadratic equations. That's where we left off when stuff hit the fan. So all right, so we're gonna go back to basic linear equations, which is a lot more like it's fine. I like it. Okay. All right, so number one, we have a couple of different just basic linear equations, just one variable on one side of the equation. So what I've taught my kids is we can make a do and undo list. And what we do is we record what is happening to the variable and what we have to do to undo that. So the very first thing that we are doing to this variable, we have a W here. The first thing that's happening to it is we are multiplying by 3. Okay? And then the next thing we do is we are adding 7. So to undo this, so our order is we multiply by 3, then add 7. So to undo this, we're going to go backwards from what we did. So to undo adding 7, we're going to subtract 7. And then to undo multiplication, we're going to divide by 3. Okay, so just so you know, we're going backwards from what we did to the variable. So first thing we're going to do is subtract 7 from each side to keep it balanced. The 7's cancel here. You're left with 3w equals 19 minus 7 is 12. Okay, then we're going to, so we've subtracted 7. Now we're going to divide by 3 on each side. My 3's cancel, and we are left with w equals 4. 12 divided by 3 is 4. All right, let's look at B. We'll make our undo list again. So we have our do and our undo. Okay, so the first thing I'm doing is I'm dividing that z by -4. And then I am subtracting 3. So to undo subtracting 3, we're going to add 3. To undo division, we're going to multiply by -4. So again, we're going backwards. Okay, so let's add 3 to each side. 5 and 3 is 8. So we have 8 equals z divided by -4. To undo dividing by -4, we're going to multiply by -4. Okay, and 8 times -4 is -32. These -4's cancel, and you're left with just z. So z is equal to -32. And just so you remember, you can always check your answer. Put that to the side. Always check your answer. In order to check your answer, you would take what your variable is equal to and replace the variable in the equation. So you would do 3 times w, or 3 times 4, which is 12. 12 plus 7 is 19. So this would be a correct answer. So you can always check it. I've happened to do these problems like 3 or 4 times now, so I'm not going to check them because if I keep getting the same correct answer, then I'm going to assume I'm correct. That being said, don't ever assume, because I promise you, I made mistakes yesterday working these out. I fixed them all, but, you know, you know. Okay, so let's start on C. Let's make our do and undo list. When you've solved as many equations as I do, you kind of skip this step and just start jumping in. So what's happening here is I am adding 6 to H first. You see how they're on the same level, H plus 6? So I'm adding 6 first and then dividing by 5. So to undo that, we'll multiply by 5 and subtract 6. You can tell I'm starting to get lazy with writing stuff out too. Okay, so 5 and 5 will cancel. We're left with H plus 6 equals 2 times 5 is 10. Okay, then we'll subtract our 6 from each side. H is going to equal 4. Okay. All right. D, we have 8y plus 3y equals 44. So here, before I make my do and undo list, if I ask you what's happening to y, half of you are going to say it's being multiplied by 8. The other half is going to say, well, it's going to be multiplied by 3. We've got two separate y's, so I like to try to get those two y's together before I start making my do and undo list. So I have 8y and 3y. If I add those together, I've got 8 plus 3. Y, which is 11y. So 11y equals 44. So this is now a one-step equation. I could write my do and undo list. I think I did in my guided notes. But right now I'm multiplying by 11. So to undo that, I divide by 11. So if I divide by 11, I get y equals 4. And yes, I realize that I have most of these are equal to 4. That's kind of crazy. I don't know. 4 was a popular number, I guess. Okay. Let's look at E. It asks us to find the measure of each angle in the polygon. The sum of the angles is 180 degrees. So we have this shape here. We don't know what the angle measures are. We do know A and A. We know these are the same. 2A and 2A, we know these two are the same, and it happens to be double this. Alright, so the sum of the angles is 180. So sum means add. So we're going to add all 4 of these angles together. So A plus 2A plus A plus 2A equals 180 degrees. Okay? So if I can combine all my like terms here too. Remember, we didn't want multiples of one variable. We wanted just one copy of that same variable. So A and 2A is 3A, plus another A is 4A, plus 2 more A's is 6A. So 6A equals 180. Again, we can write our do and undo list, but we know this is 6 times A. To undo that, we'll divide by 6. And A equals 30. Right? Yeah, 30. Okay. I am not finished. This is one of the biggest things I have to harp on throughout the year. The question was not what does A equal. It says find the measure of each angle of the polygon. So we know that A is equal to 30. So we know that this angle is 30 degrees and this angle is 30 degrees. But we also need to know these two angles. So if I take 30 and replace the A with 30, I've got 2 times 30, which is 60. So I have 2 30-degree angles and 2 60-degree angles. And to double check that, we're just going to add that up and make sure that it equals 180. So 60 and 30 is 90. 60 and 30 is 90. 90 and 90 is 180. So we're fine. Okay. All right. Try to drink some water in here. It's a lot of talking. Okay. Alright, so number 2, now we've got variables on both sides of our equation. So we're going to, before we do our do and undo list, we need to get our variables all to one side, or all combined. So what I would start with here is just like, I mean, we're going to undo one of the variables and get it to the other side. Personally, my recommendation is to always move the smaller variable so that you're working with more positive numbers than negative numbers. Sometimes you're stuck with negatives no matter what, and that's fine. We can handle it. But I just to make sure we don't have as many mistakes, because we all make mistakes, myself included. You'll see me make a mistake in this video, I'm sure. Maybe not, but I tend to make, like, you know, Miss Gallant makes dumb mistakes too, and that's okay. I've come to, you know, we've come to live with that. So what I'm going to do is I'm going to subtract the smaller of the two variables from each side, and that would be the 2p. And what that's going to do is that's going to keep me from having to work with negatives. So I have 5 minus 2 is 3p. So I have 3p minus 9 equals 12. And from here you can do your do and undo list. So what's happening to p? Well, it's being multiplied by 3, and then I'm subtracting 9. So to undo that, we're going to add 9 and divide by 3. So we'll add 9 to each side, and 3p is going to equal 12, and 9 is 21. And then we're going to divide both sides by 3, and p equals 7. Okay. Then we get to B, and B is one of those, we can approach this a bunch of different ways. So one thing we could do, we could distribute. That could be the first thing we do. And that's what I think that's our default, is a lot of times we just go ahead and straight up distribute, and that's okay. We can also divide and get rid of those numbers. It kind of just depends on your preference. I also know that a lot of kids can't stand a fraction and will do anything they can to get rid of it. So before I do my do and undo list, let's, again, you can distribute this 2/3 and this -2, but I think for my kiddos that don't like fractions, I'm going to do this trick. It's not really a trick. It's math. If you multiply 2/3 by its reciprocal, what's going to happen is this 3 and 3 cancels, and this 2 and 2 cancels, and you don't have a fraction anymore. That said, if you do it to the left side, you also have to do it to the right side. So we're multiplied by 3 over 2. So what happens is you have this -2 and this +2, and the 2's will cancel, and you're going to be left with the negative and the 3. So I have 3x plus 9 over here. I don't need to keep in parentheses because there's nothing to distribute anymore. I'm left with a negative and the 3 over here, so we'll have -3 and 2x plus 6. Okay. So again, in all of these things that I'm doing, you can do this multiple ways. Like and you're going to get all these things I mentioned. You should get the same answer every single time because they're all mathematically legal. So I can distribute the -3, or something I did notice is that these are both divisible by 3. So I can go ahead and divide everything by 3. And oh, that's a -3, so let me make sure I divide by -3. We can divide by -3. Those cancel. If I divide these by -3, 3 divided by -3 is going to be -1, or just -x. 9 divided by 3 is going to be 3, and it'll be negative. Okay, and again, you could have distributed and it would have been fine, but this left me with some smaller numbers, so that's why I did that. Then I'm going to move this x over to this side, so I only have one x to work with. So I moved it by adding, so negative and positive cancel out. Okay, and so I'm left with -3 equals 3x plus 6. Here you can write your do and undo list if you want, now that you only have one variable. Again, after a while you kind of start recognizing patterns, and you don't have to do this very often, but if it helps you, keep doing it. Okay, so I'm taking x, I'm multiplying it by 3, and then I'm adding 6. So to undo that, we're going to subtract 6 and divide by 3. So we're going to subtract 6 from each side. We have negative 9 equals 3x. We'll divide each side by 3. And we're left with negative 3 equals x. That's my husband, so say hi. Say hi.
Hello.
Okay. Alright, so let's go on to the next page. Okay. Alright. Okay, so this one I think I would distribute just because you have this number that's not in parentheses that's being added to everything, or everything's being subtracted from it. So let's go ahead and distribute. So I have 2 times 4x, that's 8x. 2 times 2 is 4. And then we'll go ahead and distribute this negative 12. Don't forget that that 12 is negative. The negative stays with the 12, so it's going to affect all the signs. So negative 12 times x is negative 12x. Negative 12 times negative 1 is going to be positive 12. Okay. Let's combine these like terms. 4 minus 12 would be negative 8. We'll add 8x to each side. Remember, we moved the smaller of the two. And I know some people are going, well, they're both 8. But this one's a negative 8, so let's add 8 to each side. And now we don't have any negatives. And that's going to give us 16x plus 4 equals 12. Okay. So I'm going to make my do and undo list. Ooh, if I could spell today, that'd be great. Okay, so x is being multiplied by 16. And then I'm adding 4 to that. So to undo that, we'll subtract 4 and divide by 16. So subtracting 4 from each side, we have 16x equals 8. Divide each side by 16. So we have x equals 8 over 16, but we all know that is not the most proper fraction. We can reduce that. We can divide both the top and the bottom number by 8, and that's going to give me x equals 1/2. Alright, word problems, because I know how much y'all love those. Alright, so I have a large reusable bottle, costs $4 more than a small one. 8 large bottles cost $24 less than 12 small ones. How much does one small bottle cost? So what we're going to do, we have to write our equation before we can solve it. So we know that a large bottle is $4 more than a small bottle. So we're going to use 4 plus S to represent a large bottle, because it's $4 more than a small one. 8 of those, so let's multiply that by 8, cost $24 less than 12 small ones. So it's going to cost or equal 12 small ones minus 24, because it's 24 less. Alright, and so now it's just a basic equation. I think the hardest part of these problems is translating words into numbers. It is like a whole nother language, like taking what you know and putting it into math terms. Once you have this, though, it's just solving. Okay, so this is one I think I would distribute here first. I think that's going to make the most sense. So 8 times 4 is 32 plus 8s equals 12s minus 24. Again, you want your, hold on, I gotta pop up. Okay. You want your smallest, you want to move your smallest one over. You want only one copy of your variable. So let's subtract 8s from each side. Those will cancel. We have 32 equals 12 minus 8 is 4, so 4s minus 24. Okay, so this is, we do our do and undo list. So what am I doing to s? I'm multiplying by 4 and subtracting 24. So to undo that, we'll add 24 and divide by 4. Okay, so we'll do that over here. So we have 32 equals 4s minus 24. So we're going to add 24 to each side. And that is 56 equals 4s. We'll divide both sides by 4. And we get s equals 14. So what that tells me is a small bottle costs $14. And it didn't ask for it, but since we know that large bottles cost $4 more, we know that a large bottle costs, if we add $4, $18. Alright, section 3. These will go a little bit quicker. These are just, do they have one solution, no solution, or infinitely many solutions? So you can solve this out to figure it out, or you can just kind of analyze the structure, and so you can be a little bit lazier and not have to actually work it all the way out. So let's just look at the structure of A. We have 3t on either side. So the variable has the same coefficient. If I were to subtract it or cancel it out, it would cancel out on both sides and leave you with something like 4 equals 12, which we know is not true. So there's nothing I could plug in for t that's going to make 4 equal 12, because these two things will always cancel out. So this has no solution. Okay, so this one, so we're going to simplify this just a little bit so that we can analyze it and make a determination. Also, let me just go ahead and put you some notes up here. If it has the same coefficient, which is the number in front of the variable, but the constants are different, like the number I'm adding is different, it will always have no solution because your variables will cancel and you'll be left with like 4 equals 12 or 2 equals 7 or some crazy something or another like that. That's not true. Okay, so we're going to go ahead and distribute here. And we're going to get 2h plus 2 equals 5h minus 7. So I want you to know something real quick. These have two different coefficients. So because they're two different coefficients, when I subtract the 2h, I'll still have 3h over here. And then I'll be able to add and divide, and I'll have h equals a number. I can't cancel out the variable. So since I can't cancel out the variable, I can actually solve it. And so there will actually be one solution. So if there are different constants, no, I'm sorry, different coefficients, wrong C word. So they have different coefficients, so they're going to have one solution every single time. The constant really doesn't matter. If they have the same constant, though, the solution will be 0. Just so you know. Okay. All right, so C, we're going to distribute the 6. We get 12y plus 6 equals 12y plus 6. So you notice we get the exact same thing. Something is equal to itself. Well, it doesn't matter what y is. 2 will always equal 2. 7 will always equal 7. X will always equal x. Like, everything will equal itself. Always. So, this one has infinitely many solutions. So this is one where we'd have the same constant, so you could cancel out the, same coefficient. We could cancel out the 12y and 12y. We'd be left with 6 equals 6, which is always true. So this is one where we have the same coefficient and the same constant. Okay, so anytime you have like the same coefficient and the same constant, it should be it will be infinitely many solutions. Alright, almost done. I know this was a lengthy video, but this was also kind of a lengthy review, so Okay. Section 4, literal equations, which I know so many people love so much. This is where you have multiple variables and you're solving for just one. The thing about this is that your answer is not going to be x equals a number or y equals a number. It's going to look like another problem. It's going to be y equals a bunch of numbers and letters and stuff. It's not going to look pretty. It's going to look like another problem. So your answers look like problems. Okay. Alright, so our answer is going to look like problems. Alright, so we're going to solve this equation for y, which means we want to get y by itself. When we do our do and undo list, let's do that first. We're talking about what are we doing to y, not what are we doing to all the other variables. So the first thing I'm doing to y is multiplying it by 4. And then the next thing I'm doing is I'm adding 8x to it. So to undo that, we'll subtract 8x and we'll divide by 4. Okay. So first thing we're going to do is subtract 8x. Now, 8x and 20 are not like terms, so we can't actually combine them and get a smaller number. It's like saying I have $20 and I spend 8 euros. They don't combine. They're not the same thing. You didn't actually touch that $20. So we're going to have 20 minus 8x. We're just going to write it. And until we know what what x is, and we might not ever know. If we knew what x was, we could plug it in and then subtract. So what we're going to do is we're writing this expression to tell us, hey, if you find a value for x, you would subtract it from here. But we're not actually going to do any physical subtraction. We're just going to write it. Okay, and then we're going to divide by 4. And we get y equals 20 minus 8x over 4. I don't like leaving it like this because you can simplify it. You can divide 20 and 8 both by 4. So we'll do y equals 20 divided by 4 is 5. 8 divided by 4 is 2. So we get y equals 5 minus 2x. So again, it doesn't look like an answer. It looks like a problem. There's still variables there. But we did what we were asked. We solved for y. We got y by itself. At the end of the day, we just want that one variable by itself. All right, B, solve sx plus tx equals r for x. So we have two x's. So if you recall what I've always told y'all in this whole little 20-minute video, 30-minute video, when you have two x's, you need to combine them. So when we combine, we need to add s and t, but they're not numbers, they're variables. So we're just going to write that we're adding s and t together, and we have s plus t x equals r. Okay, so my do and undo, I am multiplying x by s plus t. So to undo that, we're going to divide by s plus t. So let's do that. Let's divide both sides by s plus t. Okay, so these will cancel. And I have x equals r over s plus t. And that's it. X is by itself. It looks crazy, but that's it. Okay, C. We are solving Q equals F minus G over P for F. So let's do our do and undo list. So what am I doing to F? The first thing I'm doing to F is subtracting G. And then I'm dividing by P. So to undo that, we're going to multiply by P and then add G. Okay, so first thing we're going to do, multiply by P. And so I get P times Q equals F minus G. Then we're going to add G to each side. And PQ plus G equals F. I'm going to rewrite it because I like my variable to be on the left side. I know that's super dorky. Okay. Alright, and then the last one, D. This one is intentionally tricky. It took me a few tries to figure out how I wanted to do this. So we are solving for A, and we have a lot of A's on here. Well, I said that we have 2, but they're on the same level. And a lot of people are like, oh, well, you could just cancel because you have an A on top and A on bottom. But I have to divide all 3 terms by AB. So that doesn't really work either. Okay, so what I'm going to do is I want to get down to 1A. So I know most people freak out with fractions. So let's cancel our fraction. So we're going to multiply both sides by AB. Okay, so these will cancel, and I'm going to have ABX equals A plus B plus C. Okay. So then, let's get this A over to this side. Let's subtract A from each side. Now I have ABX minus A equals B plus C. Okay, so kind of like we did on B, where we combined the 2 things in front of our X, we're going to combine whatever is with our A's. So here we could rewrite this. We'll have BXA minus 1A. So we put the B and the X in front, and we put a -1 because that's a minus A. And if we were to combine like terms, we would take this B and X and subtract 1, and whatever that sum was, or whatever that difference was, we'd have that in front of A. Since we just have a bunch of letters, though, we're going to do BX minus 1 in front of A equals B plus C. Okay, so now I only have 1A. We could do our do and undo list. I'm going to skip that this time, though, because we just want to get A by itself. We have blah, blah, blah times A. Doesn't even matter what it is. It's something times A. So to undo times, we're going to divide. Okay? So these will cancel, and you're left with A equals B plus C over BX minus 1. Okay, so let's see, we are at 33 minutes. So this was kind of a lengthy video, but it was also a lengthy practice. I hope it was helpful. I hope it didn't just waste your time. If you have any questions, feel free to email me or your teacher if one of your teachers is using my videos. And I hope you guys have a great day, and stay safe, and see you soon.